So today we're going to talk about Pythagorean Theorem and simplifying radicals. So your essential question is, how can I tell if a triangle will be acute, right, or obtuse? So remember, an acute triangle has to have all three angles that are acute, which means they're less than 90 degrees. A right triangle has one 90-degree angle, and an obtuse triangle has one angle that is between 90 and 180. So it has one obtuse angle. All right. So Pythagorean theorem. Now this only works with right triangles. So the Pythagorean theorem is the formula a squared plus b squared equals c squared. This is a really important thing to put in your notes. You will be using this a lot, especially in geometry. And for this, we know that whatever the value of c is, has to be the hypotenuse of the triangle, which is always the side that is across from the right angle in a right triangle. Okay, now a Pythagorean triple are three numbers that work with Pythagorean theorem. So if I were to plug in these numbers, then they would satisfy a squared plus b squared equals c squared. So for example, 3, 4, and 5 make a Pythagorean triple. So that means if I take 3 squared plus 4 squared, it should equal 5 squared. So let's check that. So 3 squared equals 9. 4 squared equals 16. And if I add 9 plus 16, I get 25, which is equal to 5 squared. So because those numbers work, those are called a Pythagorean triple. Another really famous Pythagorean triple is 6, 8, and 10. So those are some that you can kind of have memorized, and then it helps you when you're doing Pythagorean theorem. If you notice a triangle has those side lengths, then you can automatically know what the other side will be. So it's kind of cool. Alrighty, so simplest radical form. So you guys have kind of been doing this a little bit already. But simplest radical form is when you simplify a square root so that no more perfect squares can be taken out from underneath the radical sign. So, for example, we're going to put the square root of 336 into simplest radical form. So I kind of need to know what numbers I can take the square root of so that I know what I can take out of this. Okay, so I'm going to list out my perfect squares. So I have like 1, 4, 9, 16, and you might be like, whoa, how is she getting all these numbers? This doesn't make any sense. So to get these numbers, these are perfect squares. So I would take 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. And I can keep going all the way up to 100. And you can keep going after that. But these are the most common ones that we use. And so I can take the square root of any of these numbers evenly. So the square root of 4 would be 2 because 2 times 2 equals 4. So all of these are perfect square numbers. So I want to say, what is the largest perfect square that I can divide out of 336? So I can try a whole bunch of different numbers. And I want to find the largest one. So I can try like 64, but that doesn't work out evenly. So what I find is that if I take 336, I can take 336 and change it into 16 times 21. So I know that I can divide 336 by 16. So 16 is on my list, so I can use that number. What is the square root of 16? Well, square root of 16 is 4, so I can take that out. So I get 4 radical 21. And since 21 cannot divide out any of these numbers except for 1. I can divide 21 by 1, but I can't divide it by any of these other numbers. Then I know that I'm finished. All right. So you have to, just to recap, you have to factor 336 into 2 numbers. And one of those numbers has to be a perfect square. So you can't just choose 2 random numbers that multiply to be 336. You have to choose a number off your list of perfect squares. Okay? And here again are the perfect squares from 1 to 100. Okay. Let's try some more examples. So feel free to pause the video at any time and you can try these on your own. Okay, so we have to think of, look at your list of perfect squares. Okay, what can we divide 50 by that is a perfect square? So you can divide 50 by 25. So that would be like 25 times 2. Okay, and what is the square root of 25? It would be 5, so the 5 comes out. So the answer is 5 root 2. And because 2 can't be divided by any other perfect squares, we know that we're done. Okay, I think we've got one more on here. Okay, 12. This one isn't too complicated because there's not very many perfect squares that are less than 12. So I could do 1, 4, or 9. So it's going to be 4. So I can split that up into 4 times 3. And the square root of 4 is 2, so that comes out. And I get 2 root 3. All right. Okay, so we've got some theorems from your book here. You don't need to memorize the names of the theorems, but you just need to know how to use them. So what we can do to tell if a triangle is acute, right, or obtuse is you can kind of use Pythagorean Theorem and just adjust it a little bit. So if you have a triangle and you do a squared plus b squared equals c squared, then that triangle would have to be a right triangle. So if you take a squared plus b squared and it equals c squared, then you know it's a right triangle because that's the Pythagorean Theorem. Now, if the hypotenuse or the longest side, if you square that and it comes out to be longer than a squared plus b squared, then you know the triangle is obtuse. Okay, if we try this and we take the longest side and we plug that in for c, and we do c squared and a squared and b squared, and we find out that c squared is less than a squared plus b squared, then we know the triangle is acute. So you can easily tell if a triangle is acute, right, or obtuse by plugging in the sides to Pythagorean Theorem and seeing if the longest side is greater than a squared plus b squared, then you know it's obtuse. If it's less than a squared plus b squared, then it's acute. And if it's equal, then you know that it's a right triangle. So let's try some examples of this so that this makes more sense. So it says, classify if the triangle is acute, right, or obtuse by the given lengths of its sides. So we're going to look at these examples here. So we've got 6, 11, and 14. So 14 would be the largest, so we know that that one has to be C. Okay, and then 6 and 11 are A and B. It doesn't really matter which order you write those in. Okay, so we've got to see if 14 squared is greater than, less than, or equal to 6 squared plus 11 squared. So we're going to work these out. And so if we do 14 squared, that's 196. And then we have 36 for 6 squared. And 11 squared is 121. So if I take 36 plus 121, I get 157. So if I take 196 and 157 and I write them like this, then I would have to write the symbol pointing this way. So 196 is greater than 157, which means that the triangle is obtuse because c squared was greater than a squared plus b squared. Okay, let's try another example. So we figured out that the triangle is obtuse because c squared was greater. All right, let's try this one. So we have 12, 13, and 15. So obviously 15 is the largest, so that one has to be C. And when you're writing this, you need to make sure that you always put c first. So even though the formula is a squared plus b squared equals c squared, you need to make sure that when you're doing this, you write the c part first, because we're trying to see if that side is greater than, less than, or equal to the other sides. And if you write it the other way, then your symbol will point the wrong direction and you'll get the opposite answer of what you want. So you always have to make sure to write the c squared part first. So we're going to have 15 squared is greater than, less than, or equal to 12 squared plus 13 squared. So if we do this, we get 225, and then 12 squared is 144, and 13 squared is 169. So if we add 144 plus 169, we get 313. So the symbol would have to point this way. So then we see that 225 is less than 313. So because of that, the triangle would be acute. All right. So just make sure to go back and answer the essential question to write your summary. Thank you.